Okay, we're given the function x squared plus y squared equals 25. Our goal is to find the equation of the tangent line, as drawn in the graph over on the right-hand side, that's tangent to the graph at the point 3, 4, and we're going to use implicit differentiation. So as we take a look there, we're thinking, well, it should probably have a negative slope, but we aren't going to use guesswork to get there. Instead, let's start out. I'm going to begin with our function x squared plus y squared equals 25. And with this, let's take the implicit differentiation, implicitly differentiate this function. So one term at a time, I'm going to go ahead and use the power rule. So 2x, and I don't really need to put a dx next to this. It's where we have a y that we're going to be really careful that as we differentiate the second term, we're going to get 2y. But being that our variable was y here, we want to include a y prime next to this, or a dy dx, indicating the derivative of y with respect to x. All right, that was just the power rule on the y squared. On the right-hand side, the derivative of 25 is going to be 0 because it was a constant. Our next goal is going to be isolate that y prime, get it on one side all by itself, solve for it. So let's move the 2x to the other side by subtracting it. This will leave us with 2y times y prime equals negative 2x. And to get y prime all by itself, we can divide both sides by 2y. All right. On the left-hand side, a little bit of simplifying, we're going to be left with just y prime all by itself. So this is the formula for our derivative at any point that's on this graph. Okay, but our specific point we cared about was at 3, 4. So we're going to use that ordered pair 3, 4. We've got an x value and a y value, and let's fill in to our derivative. So that'll be negative 2 times 3 over 2 times 4. All right, I guess I could have simplified down the derivative by canceling out the 2's, making that into a 1. I'm going to do it at this point instead. All right, so the derivative, when we evaluate it at that point, is negative 3/4. And hopefully at this point, we're comfortable that derivative means the slope of a tangent line. So we have a point and we have a slope of our line. Let's put these together and find the equation of our line. So negative 3/4 is a slope. We have a point. So I'm going to use y equals mx plus b. I'm going to fill the y value is going to be 4. X is going to be replaced with 3. And our m is going to get replaced with 3/4. So again, y was 4. M is negative 3/4, and x is 3 from that ordered pair, plus b. So this only leaves us one thing we don't know what it is. We don't know what b is, but we can solve for that. So I'm going to put this 3, multiply it by the negative 3/4. So I'm going to multiply numerators together, multiply denominators together. And now to get b on one side by itself, I'm going to have to add that 9/4 to both sides. So we have 4 plus 9/4 is b, but let's go ahead and get a common denominator. That would be a better answer if we made this into a single fraction. So I'm going to treat that as 4 over 1. I'm going to multiply numerator and denominator both by 4. So that's going to be 16/4, that was equivalent to 4, plus 9/4 is b. Or, putting those together, we'll keep the common denominator and go 16 plus 9 more makes 25/4. All right, so we now have our b. Let's put it all together. So we can say the equation of our tangent line is going to be y equals negative 3/4 x plus 25/4. Final answer, that is the equation of our tangent line to this graph at that point. You will notice that negative 3/4, the slope of that line, it's negative. This kind of looks like we're going down 3 and to the right 4 to get additional points on the same line. But we can be really confident that actually is the slope of this line. Now if we'd gotten something positive, that wouldn't make any sense with the graph that's drawn over here on the right hand side. So I hope this helps out as you're working on equations of tangent lines using implicit differentiation. Good luck.